In this do-it-yourself repair and maintenance video, I'm going to show you exactly how a 5-stage reverse osmosis water purification system works, and I'm also going to talk about problems that are common with reverse osmosis systems and how you can correct those problems. To get started, I'm going to reposition the camera under the sink on the RO system. You're now looking at my 5-stage RO system installed underneath the sink. Now the first thing you're going to say is, why is this stage missing? I want to explain why first. The housing developed a crack. The one that screws on, like you see here at the very bottom, developed a star-shaped crack, just like you would see if a pebble struck your windshield on your car and it starred out. This was a clear cover, and on the very bottom it had that star-shaped crack. As a result of that crack, I developed a leak, and the only way for me to resolve the issue, because I live in an area which is extremely difficult to get parts, it was cheaper for me to abandon this filter and then to add a new one, which you could see right there mounted on the wall. The one mounted on the wall in the back is actually a better filter. It's made by General Electric, and it has a much better filter installed inside this housing right here. So this one in the back is replacing the one that's missing. So we're going to start with the new filter that I installed. This is the first stage going in. Right back here you can see the on-off valve. This is connected to the feed water or the city water supply or a well water supply. Once the water leaves this filter, it then flows into the next filter right here. Let me rotate the camera. Once the water goes into this filter, this is the one that has the activated granules of carbon or charcoal. The water then leaves this filter on the back side that you can't see, and it flows into this one. This has the carbon block. Once the water leaves the carbon block, it then goes into the auto shutoff valve. Now it's very important with this system, you have to have a minimum of 40 psi on your water supply. So if you're using a well, you're going to want to make sure you're running 40-60 and have your pressure tank properly adjusted. And if you're on city water, you're going to want to make sure you have at least 40 psi. If you don't have 40 psi, the water will not penetrate the RO membrane and you will not be producing any water, or you will be producing very little water. The first filter, which would be mounted right here, this one you're going to want to change about every 6 months. This one is where the water first connects to the system, so a lot of the debris that's in your water is going to be filtered out in the first filter right here. So this one you're going to change more frequently, every 6 months. The next filter here, I usually go about a year, and I use plenty of water, maybe a gallon or two a day out of my system, so I can tell you based on my usage that this will last you about a year, this cartridge in here. The last one is the same way. You should get about a year out of this filter as well. Once the water flows through all 3 filters, it then goes into the auto shutoff valve. Now the reason why you have 3 filters is to ensure that the water going into your reverse osmosis membrane is as clean as possible. You can actually take the city water supply and connect it right into this point here. The problem is your city water supply may have a lot of minerals, scale, it may have particulate matter, and then you're going to end up clogging your RO membrane in no time at all. So the purpose of these filters is to have the water as clean as possible going into the RO membrane to ensure that the life of the RO membrane is going to be as long as possible. This part right here, I'm going to move the camera just to show you a different angle. This is your auto shutoff valve. That's a better angle. You can see it's composed of 2 halves, a thinner half on the front, thicker on the back end. The water from the last filter, alright, that comes up and goes into the thick part of the auto shutoff valve where it says in. The other side out goes into the screw end of the RO membrane. In case you screw up with your hoses, now you know where they go. On the same side, over here, I'm going to explain why I have this piece in here in a minute. Yours will not have that. This is something else I had to do because of where I live, and unfortunately I cannot get parts. On the same side is the inlet from the last water filter. You're going to have the inlet from the RO membrane. This is the clean water going into this part of the valve. This is the thinner half, So if you screw up, inlet, RO, thinner side of the valve on the inlet side with this side here, which goes to the last filter. Just remember, the screws are on top, the screws are on this side, and that's the side which goes with the RO. The other side here goes into a T, which then goes from the T into this last filter, which is the final stage, the fifth stage, and it also connects to your pressure tank, which is right over here. Inside this tank is a bladder. Now the bladder is a vinyl bag, it could be a rubber bag, a neoprene, anything that's going to allow air to go inside of it and have it expand. It's very important that this tank has the right amount of air pressure in it, which you can check by unscrewing this little black cap at the bottom here to access the Schrader valve to check the air, that it has 5 to 7 psi. Now I keep mine right around 7. In order to check it though, the tank has to be completely drained and leave the valve open. Once the valve is open, the tank is empty. Check the air pressure, make sure it's between 5 and 7, cap it back, and the tank is good to go. When you go to check the pressure on the tank, you go to pump it up, and you notice that the pressure will not rise no matter what you do, then it's very possible the bladder inside has a hole in it allowing air to escape. What happens, you have this bag that's under pressure, and the water coming in is under higher pressure, so what it does, it squishes down, compresses the air in that bladder, so when the system is equalized and it turns off, you now have this bag with air pressure in it, which is going to allow the purified water to be pushed up out of the tank and to the spout where you can get it into a glass of water. So that's how this works. Without the proper pressure, the system will not operate properly. Now some of you may ask, why have a fifth stage, this inline taste and odor filter, if it's coming after the RO membrane, which the water is supposed to be very clean? And the reason is that the water that goes into this end, this is the inlet, also goes into the pressure tank. Now the pressure tank, because it has that bladder inside, the bladder may cause the water to have a different taste. So what's going to happen as the water comes back out of the tank right here, it's going to flow into the last stage and be cleaned to remove any taste and odors that it may have picked up from inside the pressure tank. This line right here, the line where it exits, the outlet of that filter, goes up to your spout where the water comes out. Now this side of the system is lower pressure, and right here is your high pressure going into the auto shutoff. Now I'm going to show you some images of the inside of this so you can see exactly how it's made, but before I do that, let me explain exactly how this works. You have high pressure water coming in after the last filter. Goes into this auto shutoff valve. In the very bottom inside here, you'll see in the images in a minute, there's a little tiny hole and a little tiny ring with a rubber diaphragm covering it. The water goes in through that little hole and around because the diaphragm is not sealing it off, preventing the water from crossing from the hole over. So when that diaphragm is up, water is allowed to flow from the inlet to the outlet into your RO membrane. And then water flows through the RO membrane. Whatever wastewater you have will come off of this top one. You'll notice it's a little further in on the end. That's the wastewater. Right here, this is called a flow restrictor. The purpose of this is to prevent you from wasting too much water. This connects to your drain assembly, which you can see right there, it ties in. The wastewater goes into the drain. The reason why this is important, what it does, it allows the dirty water, which is not going to be passing through the RO membrane, to be flushed into the drain. If you're having a problem with the system where you don't hear the water, sometimes you hear it trickling into the drain, you're going to want to turn off the system, make sure there's no water flowing into this, otherwise when you disconnect this, water will shoot everywhere. You're going to want to turn off the system, turn off the valve on your tank, which I'm pointing to right here, which you can't see, turn off that valve, and then you're going to want to open the spout above to relieve any pressure. Once that's done, you're going to push this ring in with your fingernail, grab this tube, and pull off. You're going to want to blow into that tube to see if you can get the water to flow through that tube. If you're blowing and you don't feel like the pressure that you're putting in is going through the tube, then that may mean this is restricted and you're going to want to replace it. It's also an excellent idea. Once in a while, remove this tube and put it into a 1-quart container, and then you're going to turn on the water while the pressure valve on your tank is off. What's going to happen is you're going to have a large volume of water going through that RO membrane, and it's going to flush away anything that may have accumulated that would not wash away using the smaller opening inside the flow restrictor. So that is definitely something I would recommend you do every few months. Pop off this line, let the water shoot into a cup for about a minute, and then put it back together. That will help keep the RO membrane much cleaner and prevent it from being blocked up. Now let's get back to this valve. So you have high pressure water entering, high pressure exiting, going into the membrane. The way this shuts off, you have that diaphragm which is going to push down to cover the hole which allows the water to cross over from this tube to that tube. But the only way that happens is when the pressure in the tank gets high enough to push the piston with the diaphragm down to seal off that hole, preventing water from flowing across. And you can take a look at these images right here to get a better look what the internal components look like. Now if your water does not shut off and you continue to hear it hissing, then there's only two things that could be wrong. Either one of the diaphragms in here are cracked and leaking, not allowing a good seal to turn it off, or the check valve which is screwed into the RO housing is faulty. When that valve is faulty, once the system gets to the point where the valve shuts off and the check valve is faulty, as soon as it goes to shut off, it's going to open. So it's going to be right on that edge where it's going to remain open because you don't have the check valve holding the pressure from going backwards. If the check valve is bad, the water will go backwards, it'll run into your drain, and it will run continuously. So you definitely want to check right over here. This is your elbow with the check valve. Now in order to test this with the water off, of course, you're going to unscrew the elbow. You're going to blow through the male end where the threads are. When you blow, the air should go through the elbow. When you put your mouth on the side where the pink ring is and blow this way, nothing should pass. So you should only be allowed to pass from the RO membrane going towards the auto shut-off switch. If it's restricted both ways or if it's open both ways, it's faulty and you're going to have to replace it. Now my problem I had in the past was my water continually ran even after the tank was full, and I did inspect the auto shutoff, found it to be perfectly okay, and then I took apart the check valve and sure enough it was plugged up, like 90% plugged in both directions. What I ended up having to do, because I cannot find these parts locally and I live on an island so it's very hard to have stuff flown in, I ended up drilling out that fitting to make the water flow through it nice and smooth, and then I added a low pressure check valve right here. The line was cut, the plastic tubing was flared, and then I placed the vinyl tubing over it, and everything is clamped. This resolved my problem, and it's been like this for a very long time, and this check valve you see installed right here will more than likely outlast the one that was installed in here. If you're not having a lot of water being produced, then you're going to want to definitely check your filters, make sure that they're not plugged. You could take out the first filter, which is the sediment filter, and you could take your garden hose with a pressure nozzle and clean it thoroughly to remove any debris that may be on the outside of it, and then reinstall it. You could also disconnect the line going into the auto shutoff valve and direct that into a 1-gallon jug or a container to see what kind of pressure you have. You should have a sufficient amount of pressure. If you notice the water pressure coming out of this tube is not high, then I suggest you just swap out the 3 filters and then you should be good to go. My RO filter membrane lasts me around 2 years. If you use a gallon or 2 a day, it should last you about the same as well. Remember to flush it. Keeping it well flushed once in a while will help ensure a longer lifespan of the RO membrane. This filter on top should last a very long time. Once in a while what you may see happen is some of the carbon in here or the charcoal may start to fall apart and go into your water. If you see that, you're definitely going to want to toss this out. You should not see any charcoal or carbon particles inside your water coming out of the spout. Okay, there's just a couple of more things I want to cover here. If you go to use your water spout and the pressure is not good like you see there, if it comes out very slow, there's also the probability that besides having the pressure tank not properly set with the right amount of pressure, that you could have a restricted 5th stage inline filter, the last one that does the taste and odor. The one that I showed you is positioned on top of the RO unit. That's something you may want to look into. It's possible that did get clogged as well. If you're having a problem where your faucet is dripping, it's possible that the handle is too tight, and there is something that you can do to fix that. When you pull this spout out, there's 2 O-rings on the spout. You just pull it straight up hard. You're going to end up with what you see right here. To remove the handle, you're going to slide it forward. And you see this little T thing right here? It's brass. Try unscrewing it 1 full turn and then sliding this back on all the way, because if the handle's too tight, it's going to be pulling on that compression spring, making the valve open very slightly, causing it to leak. So that may be a problem that you're having. If that's not the problem and you don't feel like disassembling this entire thing to swap out the compression spring and possibly the washer, then the next thing to do would be just go out and get another one. If you would like to check the efficiency of your RO membrane to make sure it's performing as well as it should be, then you could take a sample of your product water right here. Purchase a TDS meter. It's an extremely useful test device. It's designed for testing total dissolved solids in the water. Now, the Environmental Protection Agency sets a limit of around 500 parts per million. Anything below that is considered safe. Anything above that is considered harmful. How the TDS meter works: you have 2 probes. You can see them right over here. When placed in water, a current flows between the probes. Pure water is not conductive, but water that has a lot of minerals or salts is conductive. The lower the number, the less dissolved solids are in the water, and the higher the number, more dissolved solids are in the water. All you have to do is just push on off. I'm going to put my finger on the hold button. You can see it's 0, 0, 0. Once it goes in, I'm going to let it sit for a few seconds. Normally let this sit for about 20 seconds, but because we're making a video, I'll speed it up. Hit the hold button, and you can see right there 16 parts per million, which is excellent. Now, this number is going to be low if the feed water coming into your RO system is very clean, a low number of total dissolved solids. If the water entering your system is 1,000 total dissolved solids, then this number is not going to be as low as you see here. If it's 1,000, you have to figure that if the membrane is doing a very good job at what it's supposed to be doing, you should have at least 80% efficiency, which means your TDS should not be any higher than around 200 parts per million when you check the water. So if it's 1,000 out of the faucet and it comes out of this one right here at 200, that's around the cutoff for the efficiency of the membrane. It's an extremely useful piece of test equipment, and it's very inexpensive, and if you're going to be servicing your own RO water, this is definitely what you should be purchasing. Hopefully you now have a very good understanding of how your reverse osmosis system works, and if you experience any problems with your system, you should now have a good understanding of what to look for to resolve those problems. If you enjoyed watching this video, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlists as well. Thank you very much for watching.